Hello, everyone. I'm assuming you can hear me. We want to welcome everyone to the presentation today. I believe it's our fourth Edmonton AI/ML Business and Data Science meetup. We've got a really good event today, really interesting event, and I just want to make sure our other speakers come up to the stage. I see Daniel May there from T-Rex, but we're waiting for Chris and Stephen and Peter, so they're there. So now we just need Stephen to come up on the stage. So while they're doing that, I just want to make a quick introduction and welcome everyone to the event today. Just as a bit of history, Corey Jansen and myself, we organized the Edmonton AI/ML Business Meetup, and Marcin from AlphaML, he organized the Data Science Meetup, and we decided last fall that we should actually combine the two together. And we find there's a really good dialogue between, the business applications of AI and really the data science side of things. So one more business, one more data science. And so this is our fourth event that we've done together. We're actually got some plans which will be announced in the near future about expanding this even more. And I'd like to first off just actually thank AlphaML for sponsoring these events and allowing their staff to participate and get involved. When we hold these events live, AlphaML buys breakfast, so really appreciate their support in the community. The other thing that I want to say is, if my screen would advance, hang on a second. Is that we're always looking for speakers, and there's a email address on the screen, gig-ds-meetup@alphaml.com. If you have an idea for a data science speaker or someone that's using AI in a business application, we're always open to ideas. So we really appreciate if you could send us some ideas through that email address. So with no further ado, what we're going to do today is have two speakers. The first one is going to be T-Rex AI, and that's going to be followed up with a presentation from Databricks. We're going to have about a 10 or 15 minute presentation, and then if you have questions, please put them in on the message board and the chat side of things. There's a Q&A tab there, and I'll ask those questions at the end. So please feel free to ask questions. And we're also, all the presenters and the speakers have agreed to stick around afterwards. They'll be around to answer questions as well at the end. So I first want to introduce our first speaker today, who is Stephen Zhang, who is co-founder of T-Rex AI. And this is a company that's actually participating in the Startup Edmonton Propel Accelerator program. Stephen's co-founders are Daniel May and Peter Atrazhev are on the screen as well. They all met as students at the U of A. Daniel and Stephen are finishing up their PhDs, and Peter's finishing up his MSc in the Department of Electrical Engineering. And so their work is really interesting. It's at the intersection of AI and in particular deep learning as related to really the energy generation sector and energy management systems. So when you think about all the new energy sources that are entering the grid, all the renewables, it's causing, actually I didn't know this, a lot of problems in the grid and a lot of things that the energy companies have to deal with. So they're using AI, tools that are going to help those companies manage those changes. And this is actually going to lead to some really interesting challenges and opportunities down the road. So our speaker today is going to be Stephen. He's going to speak. Daniel and Peter are going to be on the screen as well, just to answer questions. Stephen, as I said, is a PhD candidate at the U of A. He has his BSc in electrical engineering at the U of A. He's also got 6 years of software engineering, 9 years of an embedded systems experience, and he's also formerly a design lead at Atco Electric. So if I could ask the other guys to turn off their cameras, and then Stephen, I'll ask you to share your screen, and over to you.
Bruce, can everyone see my screen now?
Yeah, we can hear you and see you.
Perfect. So I'm going to get started. Good evening, everyone. I am Steven. I am the CTO of TRX AI, and tonight I will be telling you about how we are planning to enable an AI-powered energy future. Well, every once in a while, society experiences a dramatic and disruptive change. 120 years ago on Easter, New York was full of horses and only one car. Merely 13 years later, New York was full of cars and barely any horses. We're in the middle of one of these disruptive changes on the energy system right now. So over the next decade, we expect to see a huge influx of renewables, batteries, electric vehicles onto the grid. And the grid needs to adapt to these new dynamic and movable energy sources. If not, then the disasters that we've recently seen in Texas may become more frequent. And with a net zero goal of 2050 looming upon us, right, we have less than 30 years to go. The question is, can we even get there on time? So to answer that question, let's start looking at the current design process to transition us to a more renewable-centric grid. For example, if EPCOR wants to integrate solar panels, batteries, and EVs onto the grid, what they do first is model the behaviors of these devices. Then they work in conjunction with predictive behaviors of humans to figure out where the locations of the cars are and how the batteries are going to be charged and discharged. With all of these models in the system, they will design a policy that can codify all these behaviors. After the policy is done designing, they will try it out in a pilot project for at least a year to see how well it works in real life. If it works, then they'll roll it out to the general public. If it doesn't, then they have to start this process all over again. And this process is time-consuming and very costly. Pilot projects, you want complete data, so it can take a year at minimum. And then the cost can go up to millions of dollars. So if you want to get there in 2050, this process is not sustainable and is not scalable. Not to mention the pace of change may be even faster than the speed of iterating through the pilot projects. So we can do better, and that's where TRX comes in. TRX comes in with a two-part solution. The first part is our software simulator, also called TRX. I designed this over the last 4 years because there's nothing out there that would allow me to do the type of AI research on the energy system. So over the last 4 years, the simulator has been refined to be very fast and very real. It's so foundational for the rest of the company's work that we literally named the company after it. What it allows us to do now is to have digital pilots in digital twins on existing systems. And we can do these pilots thousands of times faster than the real world. For example, 2 weeks ago, when I was studying the best type of market that would work with reinforcement learning agents, I did about 20 years of iterating in less than 7 days on my gaming PC at home. So this is the type of speed and efficiency we need to get to the 2050 goal. Within this virtual space, then we can focus on our actual AI solution. And the type of AI we decided to focus on is reinforcement learning, specifically deep reinforcement learning. Why deep reinforcement learning? Well, as I've said before, the grid is going to be evolving at a rapid pace. So we need a solution that can adapt to the speed and scale of evolution. And reinforcement learning is perfect for that application. The other thing about reinforcement learning is scale. Like, we can scale our solution using multi-agents. And if we play it smart, the independent agents can collaborate through competition so that we get the most optimal economic benefits as well as the best energy balance. So going back to the design pipeline, what does it look like with TRX in the mix? Well, now all EPCOR has to do is load up the existing smart meter data into the virtual space. And the smart meter data already contains human behaviors. Additional devices and loads generation devices such as existing buildings, solar panels, where batteries to be added, and electric vehicles can also be added to the same space. And we can have reinforcement learning agents attached to each one of them so that the grid configuration is independent. Over time, then these devices can compete with each other, and they can produce multiple optimal energy management systems that are specific to the area that they're located in. So overall, we'll have a much more efficient grid because the energy management is much more specific and much more targeted. Now you may ask, why is having an efficient grid important? Well, the answer is for the utility companies, they'll be able to defer a lot of the upgrades to a later date, or even just prevent them from happening at all. Just to give you some ballpark numbers, a kilometer of above ground line can cost tens of thousands of dollars. Underground line can cost 10 times as much. For smaller transformers in the community, they can go anywhere from 10,000 to hundreds of thousands of dollars. Larger transformers at substations can go in the tens of millions. So the longer we delay these upgrades, the more money that can be invested back into the grid to make it even more efficient and even more resilient. And this is how we're going to get to the net zero goal in 29 years. But we're not stopping there. Because the T-Rex architecture is so modular and so scalable, we can deploy our solution anywhere, anytime. So we can start with one or multiple homes in a community, and the neighboring communities can do the same thing. And they will just self-form into a optimized energy management location by themselves. Once we have enough communities, they can also start trading energy with each other across using the existing wire infrastructure. And sometime down the line, we can even use electric vehicles as another way to transfer energy between regions, so that together the grid becomes even more resilient and much more distributed. And this is our vision of how to bring an AI-powered energy future to the world. What makes us qualified to do this, and you might ask? Well, besides me, we have two excellent machine learning experts. Daniel May, our COO, is an expert in deep learning and deep reinforcement learning. And Peter Atrazev, our CFO, is specialized in multi-agent reinforcement learning systems. Together, we have the expertise to bring the technical side to life. And we also have a really kick-ass mentors and advisors team. Dr. Muslik is our current supervisor, and he is established in both AI and energy systems with decades of experience under his belt. Dr. Matt Taylor is a world-class expert in applying machine learning and reinforcement learning to real-world problems. And he recently returned to the University of Alberta from Borealis AI. Dr. Andrew Leach is a world-renowned authority in energy policy, regulation, and economics. Tonight, we're looking for two more industry experts to join our advisory team. The first one would be someone experienced in working with industry partners, and the second one would be someone experienced in commercializing AI products. To hit our ambitious goal of 5 active pilot projects in 2021, we need your help to connect us to high-level executives and innovation leads at energy companies. We're already talking to MMAX, so if any of you can connect us to similar companies like EPCOR, the City of Lethbridge, ATCO, or even companies in the States, please let us know. And to be able to do the 5 active pilot projects, we're looking to expand our team. So we're actively looking for non-dilutive funding sources at the moment. If any of you know which one we should pursue, please let us know. That's just an intro for our work tonight. So thank you for listening to our presentation. I'll be happy to answer your questions now.
Thanks very much, Stephen. That's a really interesting presentation. So you'll be available for questions afterwards in the chat rooms. But I'm actually kind of curious to know. So I have a couple questions. So one is that can you actually just expand a bit more? So as I understand it, you're trying to create a digital twin of the energy system that EPCOR has or ENMAX has overall. Is that the case? Can you just talk a bit more about kind of the RL tie-in?
Sure.
Or if Peter or Daniel want to answer that.
Daniel, you want to jump in?
Yes, I guess I'll take it. I just have to figure this out. So the whole idea is that with the new energy sources that are coming, the transition times between, like, the volatility of the system increases a lot. So what's going to happen is that right now the system is reasonably easy to manage, because a coal plant, for example, if you turn it on, it's going to give you power, unless it is broken, which really rarely happens. However, a PV plant, like on your solar rooftop thing, is subject to a lot of supply volatility because of clouds and everything. So the speed of change of your generation is really fast. So to address this problem on an engineering level, what you need to do is you need to increase the speed at which your system can respond to minutes. And right now we're working at a level of hours. So with current approaches to how energy management is done, this doesn't work. This is where the reinforcement learning part comes in. Essentially, instead of doing top-down control, what we're trying to do is we're trying to use a simulation to train reinforcement learning agents, similar to what Google did with AlphaGo or what OpenAI did with Dota 5, for example, if people from the industry should know, that learn to coordinate those resources with each other in this digital twin by themselves. And then when we deploy them to the real world, they can do the same thing at the same speed independently. So you don't have to have a human operator who's going to panic, because there's a little bit of shade, we have to change everything and power up the plants. The machines are going to just smooth sailing do it by themselves.
Okay. And also, is there like a sweet spot sort of company? Is it like that could be a good customer? Is it any company that runs a grid like an EPCOR, or is there a kind of particular company that would benefit from this? And is it anywhere in the world? Like, does it have to be, you mentioned you want to get contacts with Canadian and American companies. Are there any issues in terms of type of power produced, or like what's your sweet spot client you'd like to secure?
Steve, you want to take that?
I think that's a Peter question.
What kind of companies we need?
Yeah, is there a sweet spot of customers that you'd like to have? Is it just an EPCOR or an NMAX, or are there actually, are there a different type of energy, like someone who has coal or whatever? Is there any particular tie into an energy source, or does it matter?
We would benefit mostly with utilities that are looking to get more solarification and or adding more batteries to their systems. Using these new novel, we would call them edge sources, is definitely where our system can give the most value.
Okay. So a couple questions from the audience. My good friend Gord Cruikshank is asking a question, and I'm not sure what this means, but he says, how would the AI system prioritize between critical sources or sinks?
I would really like to answer this, but first I would like him to elaborate a little bit on this question, if that's possible.
Okay. So I'm going to ask Gord, if you're still there, Gord, to maybe just add in a few more words to elaborate on that. And while we're waiting for him to do that, Corey is asking, why not raise a round? Like, you didn't have that in your ask. Are you looking to raise capital in the near future?
No, not as of right now. We're not at a stage where we think we can evaluate ourselves high enough that it makes sense to significantly raise capital. So what we're looking to do at the moment is work with non-dilutive funding sources, as Stephen said. So what we're trying to do essentially is get to research grants, because we're still in a very early TRL stage, for example, or figure out other ways to government grants like the New Energy Tech Fund or other things, to get a small seed amount first and then go from there, hopefully.
And then would that allow you to generate or create a minimum viable product, like something you can actually demonstrate it?
Yes, that's the idea.
Okay. Also, we have another, Curtis G is asked, who have you pitched to date, and what were their reaction? Any objections? Like when you talk to energy companies, are they pushing back in any areas?
So there's usually two types of reactions. Sometimes they come at the same time. We've pitched to several energy companies over the last few years while this idea was brewing. So our communication of our vision of this might have improved, which is why maybe the reactions have changed over time. In general, there's two big questions. Number one is the feasibility question, which is why we're doing this research at the university, and now we're like reasonably sure that we can somewhat pull this off. And the second one is most of the utility companies we've talked to are at a stage that they have somewhat collected meter data, but they are required to collect more higher resolution meter data by regulation, but they don't really know where to start. So what we would be doing is we would be giving them a use case to actually collect high resolution meter data, which is why a lot of, like, at least the two companies that we've like actually talked in depth to now are very interested in what we can do, and we have a few other leads at the moment going on, which also seem interested. No big objections so far, but we also haven't had the crazy big contract that gives us billions of dollars. So maybe nobody's honest enough.
All right. Okay. You'll get lots of objections, I'm sure. You always do. So Gord Cruikshank is elaborated a bit. He says some energy users require uninterruptible power. They would benefit from a prioritization of some sort. Currently, this is done with supply contracts, amongst other things. Does the AI system have a way to prioritize the consumers, which are the sinks? And then he also adds, you also mentioned that the suppliers have a priority, which was also a reliability, availability function of the class of generator, like nuclear, coal, natural gas. This side also has a priority. So does that give you enough to
Yes, it does. So he's raising a really, really good point that's basically the crux of the whole energy management thing in general, that some things really need to run, like hospitals, for example, and some things maybe don't actually have to run, like power supplies at residential homes, even though it would be nice that they would. What we're doing, like the way the system would be trained is in the simulation, we have, I don't know how much Gordon knows about reinforcement learning, so I'll start to elaborate a little bit first and then I'll come back to it. So what happens is you have an agent that we'll just call the AI, and it sits in an environment, which is our simulation, and it interacts with that simulation through actions, and it gets a feedback signal, which is a reward. That reward is a arbitrarily complex signal that can include those types of considerations as well, right? So this is a question of reward shaping in the end. So the short answer, I guess, is yes, we can make sure that this is ensured. The long answer will be, it will be ensured similarly weakly as it is right now in the electricity system, because even right now in the electricity system, you don't have 100% guarantee that those prioritized things still get energy. If in a Texas case, they wouldn't, right? And the goal would be to avoid this worst case, which I can't really make any guarantees for right now.
Okay. All right. So if I know Gord and Gord, if you want to connect up with these guys, I can make the connection. We also have a question from Andrew Eisenhower, who says, are you competing against the in-house team? So I assume that means, isn't EPCOR and NMAX doing this themselves in-house?
So the reasonably safe answer is they're probably thinking about something like this. However, historically speaking, grid companies have been really bad at innovating. Part of this has to do with their main company goal, which is making sure that the electricity system is reliant. Part of this has to do with the skill set that is required to be in such an energy company, which is usually an electrical or mechanical engineering background. And where we're coming from is kind of left field. As academics focused on AI applications, we are electrical engineers by start, but we had the luxury of just zooming in on this one totally utopian idea. So it is very safe to assume that we have a massive know-how advantage compared to those in-house teams.
Yeah, and as Corey has said in the chat, there's very, very, very little RL within in-house teams, so that gives you us an advantage. We got time for one last question, and that is a question from Curtis saying, what is your plan to monetize the system? Is it a service or is it an on-prem solution that utilities would license from you? Do you have an idea of what that is?
I can answer to both of those. So the first one is we are essentially following a two-sided business approach. We would be licensing the simulation on the one hand. And on the other hand, those marketplaces that Stephen talked about in the enabling an AI-powered energy future slide would probably work on some really minuscule market fee, like 1% or something, which would basically cover the infrastructure costs and then like a little bit of profit on top, which is basically.
Okay, so on that AI future slide, kind of the idea is, I've got solar panels on my roof, but I can sell that back to the grid. But in the future, you're saying with your system, I'll be able to sell that to my neighbor who might need it. So you're actually creating a
Yes, not only this, it goes a couple of steps further actually, right? So you're not only selling it to your neighbor is also buying at a very specific, assuming he has a battery, he would be buying at a very specific point in time where where the AI system knows that it can use residual power of the battery later on. Right? To, for example, sell things at night where there's no solar power, right? So what we would be creating is this autonomously coordinating energy community, basically, that uses the power of reinforcement learning to solve all those big control problems like the temporal shift and the intermittency of renewables.
Okay, great. Yeah, that's I know it's down the road, but that's kind of one of those Steve Jobs, just one more thing. Yes. That sounds like an absolutely massive opportunity. So that's great. Thanks very much, guys. If I could ask you to turn off your cameras and stop sharing the screen, Stephen, I'm going to switch it over to Marcin, who is going to introduce Chris Chalcraft from Databricks. So over to you, Marcin. Thank you.
Hello, everyone. And the next presentation is from Chris Chalcraft that will present Databricks to us. Databricks is really amazing platform that makes ML developers' life much easier. And Chris will tell us more about it. Chris, the stage is yours.
Hi, thanks for the intro. Okay, let me just get set up for my screen here. Let's see. Okay, so I'll start off with like a quick quick intro. So my name's Chris Chalcraft. Yeah, solutions architect at Databricks. I worked in the energy industry for about 10 years, geophysicist, data scientist, and now currently at Databricks, with kind of focus on a lot of the space of the energy vertical. And so Databricks is a company. It's a data and AI company across the globe, and it's really focusing on a lot of these kind of like core open source technologies, primarily Spark for distributed computing, Delta for like bringing structure, reliability, and performance optimizations to your data lake, and then MLflow for model tracking. And these are kind of like wrapped up really nicely within the Databricks platform. Sorry, hold on. Oh, sorry, I was in the wrong presentation. Like currently, like the data architecture, a lot of these data science initiatives and projects within companies, like they're really complex. There are a lot of different data sources. They need to be moved, transformed around. You might be dealing with different streaming data sources that you need to tie in and enrich, maybe dashboards or something like that. And then there are so many different tools available, that you can choose from, and then trying to integrate everything together and make everything work seamlessly is like a real nightmare. And I guess probably one of the biggest negatives is really kind of like this disjointed working model between the different personas within the companies, right? So you'll have data engineers kind of throwing the data product over the wall to the data scientists. They might do some modeling, produce maybe another data product, some predicted data set, that the data analysts are then using for dashboarding real-time purposes. And you know, there's no real kind of like unification between all these people, and it can cause to a lot of mistrust within the organization, and potentially a lot of rework and the ability and like problems with reproducibility. And so what Databricks really tries to focus on is this concept of a lakehouse, and that's kind of like using the data lake as your primary source for both your BI and ML workflows. Yeah, like, sorry, I honestly picked the wrong presentation here. Yeah, so the idea is that you want to have your data lake to have your structured, semi-structured, unstructured, and streaming data, using Delta as a way to provide that kind of like data governance, data management, and so you don't have this kind of mess of files within the data lake. And then it being able to serve all these different types of workflows, right? Data engineering, BI, real-time, data science, and ML. And like the three components are really try to keep things as simple as possible, try to keep everything as open as possible by leveraging open source tech. Open source tech and formats. And then also making it a very collaborative experience so you can cater to all the different personas within the company. Sorry, I'm just gonna skip ahead here. Yeah, and then with respect to some of like the open source tools, like they're growing a lot in terms of monthly downloads. And then there's like a pretty rich ecosystem of tools that are available to integrate with the Databricks platform, and then they're available across the three different clouds, right? Azure, AWS, and Google Cloud. And so, you know, you're not really locked into one specific cloud, and you can really, let's say you want to store your data somewhere, maybe S3, but you want to do you know, processing on Databricks and serve it on AML or something like that. You know, and so you can kind of mix and match these in a hybrid cloud environment, depending on your needs. Yeah, and then finally, yeah, just like bringing all this together: models, dashboards, code, and data sets, and this collaborative aspect will really kind of streamline the work and make sure that you can kind of like break down any walls and barriers that you might have within your organization. So that was kind of like a little bit of a pitch, but my goal here is I want to walk through a demo. So going through predicting life expectancy from health data. And we're going to show kind of how you can do your data engineering, data science, data engineering, your data science, whether it be the exploratory data analysis, as well as the actual modeling, hyperparameter tuning, and then also be able to take that model, serve it, and make it consumable by downstream operations. So kind of like a quick overview, just to kind of orient people within the workspace here. So on the left-hand side, I'll have things like Workspace, which provides kind of like a file-based structure where you can create different notebooks. These are kind of like Jupyter-style notebooks, but they allow you to select different languages like Python, Scala, SQL, R, and then you can specify the compute necessary. And then repos is something for like Git integration. Data, you'll be able to take a look at different data sets that are accessible. Clusters for cluster management. Jobs for any scheduled jobs, models, and so on. So that's kind of the left-hand side here. And so I can open up a notebook. This is the one that we're going to go through here. And I can immediately attach it to some compute that I have available. So you saw under the the clusters page here, you can quickly create clusters. And so this is one that I'm just going to connect to. This is like a shared one, but you know, it has certain specifications here. 92 gigabytes of memory, 16 cores, kind of like what type of runtime you'll have. So this is kind of referring to like Spark and Scala versions. And then one important thing that I'll mention here is that it comes provided with an ML runtime, which is really useful because it provides kind of like a consistent environment across the many users that you have, you know, and it comes pre-installed with a lot of your popular ML frameworks, yeah, TensorFlow, PyTorch, and so on. But then obviously the ability, if you wanted to come in, you can obviously install different new libraries or custom, custom connectors, or if you've written your own package, you can obviously install that kind of stuff in your own on your own cluster. Okay, so hopefully that kind of gives people like a little bit of a gets people oriented here. And then so now this notebook environment, we can kind of like mix and match the Markdown and Python code here. You can see at the top, I'm saying I'm running Python code. So a little bit about this data set. So we're going to take a look at, so we're again predicting life expectancy. And we're going to look at some World Health Organization health indicators. And that's going to be like our primary data set, right? And then we're going to take a look at some other things. So maybe some stuff from the World Bank. This is going to be like our enrichment. And then some drug overdose data. So I'm just going to run this to, kind of like Shift Enter or Control Enter will run the cell, just like your Jupyter notebooks, and kind of providing this familiar interface is what, a lot of people coming out of university or who are kind of, in the data science community are pretty familiar with like Zephyr and Jupyter notebooks. And so this kind of provides like a nice way for them to kind of quickly get going and kind of orchestrate their workflow. It uses this % command here, like this is a % magic command. And this is just indicating that I'm going to use a file system command. And so you can, it uses kind of a subset of, Linux-based commands. So I'm just going to list, you can mount your storage on the Databricks file system. So you can have access to like your data lake, storage accounts, different containers that you might want to. And I mean, this again is a pretty strong point in general, because it provides like a consistent data access across the organization versus kind of people, sharing data, I don't know, emailing Excel files to each other, or maybe some other kind of like poor data management practices. So this kind of makes everything nice and consistent. And so I'm just going to list here. I'm going to list what's in this directory. And so this is just going to be a bunch of CSV files for different countries. And I'm going to just list again here. This is for format 2. And again, just a bunch of CSV files. And so I'll just execute a command here, file system head, and we'll take a look and see what that data looks like. So it is just a CSV file. We have some kind of messy data here with like the first row. So let's just load in a sample and take a look and see what it looks like. So here, I guess another thing that I'll mention is Databricks comes, for those who like build kind of like Spark applications, the Spark context is already defined, and this Spark object is defined in the Databricks runtime. So just in case anyone was wondering why you didn't see any configuration. And so you can just do like a spark.read CSV. We're going to say, yes, we are going to read a header, and we're going to load it from this specific location. And so we want to be able to fix this this first row here. But then just generally, I guess we can kind of like look, and you can see there are specific codes for and the kind of like the descriptions on what they are. So here, this next cell, I'm going to say, okay, well, even though I'm in a Python notebook, maybe the data engineer is more familiar with Scala, and they want to kind of use that for some of their data processing. So I can just use the %Scala, just similarly like how I did the %file system. I'll do %Scala here, import kind of like the data frame API. And now I want to read in some of the data, all of the CSV files from this path. So you can define a function to kind of transform the CSV, and we're going to filter out that first row that starts with number, right? And so we're going to take that function, and then we're going to apply it to both of those directories, the help indicator format 1 and format 2. And so now we're going to have our, let's call it our raw data set in here. I'm going to remove, again, use a file system command to recursively remove anything from this description folder, just because I've run this in the past. And then I'm going to save those codes as a descriptions table. So here, I'm just doing a write. I'm using the Delta format. I mentioned that kind of in the intro presentation, but the Delta format is really encouraged for kind of like data lake reliability and performance. And I'm going to save those descriptions here. And then I'm just going to display it back. So I'm going to saved it, and now I'm going to read it back from that specific location. And so that's working. And so now that I have this data set, now I kind of want to do some data engineering on it, right? So I'll import some of the functions that I might need to use, right? A user-defined function, I want to explode, maybe something related to types. And I'll go through and I'll, this would obviously take some like exploration on the side, so you can kind of create kind of scrap stuff, but this is obviously pre-done. So, we want to, the key takeaway here is that we want to just perform different types of operations, right? We want to be able to filter, we want to be able to drop specific columns or specific things in our data set. We can transform like to numeric values, right? To make sure that we don't have any types of issues with that kind of stuff. Here's like we can define a function that is going to read like a string, right? And convert it to a date time. So we can take, okay, hey, I have this function here. It's going to look, it's going to split it by the dash. It's going to convert it to an integer. And then we're going to apply it to that column, right? To that year column. So anyways, you get the idea. So you can do some data engineering steps here. So let me run that. I guess I should run it in real time here. The one key thing that I'll mention here is that we're going to create a temporary view called health indicators. And so this temporary view is going to allow us to query it using basic SQL commands. So like, let's say, hey, sure, I'm using kind of like Scala or Python for my data engineering workflow, but for just kind of like quickie analysis, maybe I just want to write some short SQL commands, and I can just do, hey, I want to select all order by country and year, and you kind of take a look and see what the data set is. So now we have country, we have year. I think we filtered by 2000 less than or equal to 2018. So you can see, okay, the country and up to 2018, and then over again from 2000, and then all of our indicator variables as columns. We can check the schema. We can print out. We can say, okay, we can make sure that the types are all okay. And then our life expectancy column is this one. And so we can just take a look at that. And one thing that I'll mention here is that you can view it as a table view, or you can view it as a plot using this kind of like built-in display command. And so, you have certain plot options within here. So if you're just doing basic kind of data exploration, you want to make a quick interactive plot, you can do so. And then the only thing that I'll mention here for those interested is like, so obviously life expectancy, is expected to go up over time, but then for the US, which is indicated in this purple line at the bottom, the life expectancy takes kind of a turn, around like this 2010 and so on, right? And kind of dipping pretty heavily in 2050. Okay, so now let's introduce some supplementary data. So I'm going to add some indicators here. So this is going to come from raw data path. So this is going to come from the World Bank. And so we have a lot of features here. We're going to do the same thing. We're going to save our descriptions, and we're just going to append. We're going to append that data set, right? So we can kind of keep the list of all of our feature variables. I'm not going to go through this one, but it's the same story. You're just doing a bunch of kind of feature engineering and producing kind of like a view that you can then query. So called indicators. So I can kind of select that one there. Kind of create like a little view just to make sure that your data is okay. And then I'm going to load the last data set here. So I'm going to load in my raw overdoses data set. You can see cocaine deaths, illicit drugs, opioids, alcohol. And then I'm going to create that final view. Okay, now I want to create my final input data set. So I'm just going to remove the stuff from my input column because it's already there. And I'm just going to do a SQL join, the left outer join across all these data sets, and combine them all together as my now input data set. Okay, give this a sec here. You see all the jobs. Yeah, I won't go into it now, but you guys can look into kind of how Spark works, but it's kind of like lazy evaluated with transformations and actions and what is happening in each job and stage. But you can kind of see that stuff there. There's the Spark UI as well. And so now here I'm going to use a database. So database is just kind of like like your Hive storage within Databricks. And so I'm going to drop this database as it exists, remove everything, and then I'll create it and I'll make sure to use it in this project or in this notebook rather. And so that's also really useful, right? Like when you're collaborating on a specific project, you could say, hey, we're going to use this database like kind of locally within the Databricks workspace to make sure that we kind of control all of the data before writing anything back out to storage. And now I'll create a table that has my input data set. I'm going to call it Gartner 2020. And so I can go over to my data tab now, and I can, sorry, one second, data. Okay, let me just go to my data tab here. And so I can look at my, I can now have this data set called CChalk, and I have this table in here called Gartner 2020, and I can just take a quick glance at, hey, what does the schema look like? What does some sample data look like? And any kind of historical processing that has been done. I won't go into it now, but the Delta format kind of version controls what different types of actions and transformations are occurring on your data set. Okay, so let's see here. Oh, and then, yeah, so I wanted to make sure that, yes, I can do that with SQL, but then I can also do it just with the data frame API as well. Okay, so now let's go into the modeling stage. Modeling stage, so I'm going to read back in that table that I created. So I'm reading from CChalk Gartner 2020. That's my input data set. And this shows that it's going to be really easy to convert from a Spark data frame to a Pandas data frame if need be. You can just convert using this toPandas method. If you needed to do something, collect it on the driver and be able to do some kind of group by forward fill or whatever, and then it's really easy to transfer back. to create a data frame from your input pandas data frame. Okay, let this run for a second here. And then, oh, come on, run. And then, so the next thing we're going to show is that we can, we can do those display functions that were in the notebook, but then we can also use kind of more like custom plotting functions that we might have. Sorry, I don't know why this isn't running. Oh, this isn't loaded yet for some reason. Oh, okay. Give it a sec here. Sorry, I guess it just took some time to read back that data. Okay, so now we have the data set here, and now we can create just like custom, like maybe Seaborn, ggplot, matplotlib type stuff. If you had something a little bit more custom that couldn't be done through some kind of quickie, drag and drop plot analysis. So we can do that. So we can take a look at, hey, here are some kind of indicator variables like literacy rate, spend per capita, GDP per capita, target life expectancy. And so then it can render it right here within the notebook. And so you can kind of create this, these paraplots. And the only thing that I'll really mention here is like, obviously you have this kind of like big thing stuck out from opioid deaths from the US. So there's like this, obviously this huge spike in the US, and also kind of on the, what is this one, WH7. Yeah, per capita spend on health versus GDP, right? So obviously like versus the GDP, US is spending a lot on health. Okay, so I can create a featureized data set. So I'm just going to remove that again. This is just kind of removing doing the kind of encoding for the countries. And then I'll do the same thing. I'll save it as a featureized data set and then create a table so people can now use this featureized data set for building models, right? So somebody could take this data set and branch off into different notebooks and try different modeling techniques using that data set, because now it is available. I can go back to my data tab here and I can refresh and I can see I have my descriptions, my input, and now I'm with my featureized data set. So now I want to do some modeling. What I want to show here is that there's something called koalas, which is a Spark API that mimics the pandas API. So for those of you who are more familiar with pandas, it kind of allows that pandas style syntax, but then executing it on a Spark data frame. Because we know that it can be quite a barrier sometimes for people who are not familiar with this kind of like big data distributed compute style to come over and like seamlessly integrate into that workflow. So this is seen a lot of pickup recently. And this is another open source project, so it's being like really actively developed. So this is just kind of creating the train test data set with our life expectancy as the target variable. And it's doing that on the koalas data frame, and then once again, it's writing back out to pandas. This will run. A sec here. So let me move on. I'll just wait for this to run, and then so the next thing that we're going to do is, so now that we have our pandas data set are split into a train test, now we're going to do some hyperparameter tuning. So we're going to use hyperopt, which is a library for like a Bayesian optimization of hyperparameters. And then this will allow us to take an input pandas data set, but then it'll transform it behind the scenes to a resilient distributed data set and execute it in a distributed fashion behind the scenes. So we're going to use an XGBoost model. Let's see, this run. Okay, an XGBoost model. And we might want to create a search space across all these different types of parameters, right? Alpha, learning rate, max depth, and so on. So we're going to define a function to train our model. And one thing that I'll mention is we are using MLflow to log parameters here, but hyperopt as a library will do the automatic logging of your experiment, so you can kind of compare and contrast them. So this is here, it's running. So I have a parallelism of 6, and it's doing 10 evaluations. So we'll wait for this to go, but on the top here, you can see that the experiments are now being created, right? So I have, in this experiment tab, I can just kind of quickly view, and I can see, oh, hey, you know, some of them haven't run yet, obviously, but I can see what were some of the input parameters that we're using in this experiment run, what was run at that specific time, and I can pop this out into a new window. Sorry, I'll try to speed it up here. I think I'm running out of time. But I can spin this. It has like the specific run that was used. It has all the parameters that were in that experiment, any tags that you might have. And if you had any artifacts recording like an image, you could do that. So wait for this to run here. Wait for all the experiments to come up. Let me go back here. And so you can see this kind of gives you like a little bit of a summary style of, hey, what experiments were run? What time were they run? What was the source that created them? And was there any model that was generated from that experiment? So I can spin this out. I can kind of compare. I can compare a bunch of models. I can, you know, maybe like just go like this, click compare, and it'll bring this up, and you can say, oh, you know, what were the, across these different runs, how did my parameters change? I could look at maybe like a scatter plot over specific variables, or the parallel coordinates plot is pretty popular for hyperparameter tuning if you have like a metric that you're measuring against, and what different types of parameters that are changing with each specific run. And you can maybe, you know, you can highlight a specific one or whatever. So that's good from the experiment tracking side of things. And let's see. And so now I want to just go, now that I have this experiment tracked, I want to just grab the best run, right? So I want to find so this logged the best iteration, but I'm going to come and I'm going to look at my experiments, and I'm going to start this MLflow. I'm going to train a model using my best parameters from my experimentation. And I'm going to log an artifact with it. So you can look into it. You can look into like MLflow API, but you start a run essentially, and then you log different parameters associated with it. So here I'm going to log the parameters, the model itself, and then I'm also going to log this artifact, which is a plot that's associated with my model. So I can come over here and I can see in my experiment run, I now have this models tab. I have this XGBoost model. Let's pop it off. So this kind of shows me what were the parameters, what was the metric, and I can come and see, oh, it has my model. If I want to, you know, build it into some kind of build release pipeline, and that artifact that I was saving. Oh God, okay. So it also logs that artifact, right? If I have some kind of maybe model interpretability type thing that I want to save with my model. Okay, so I'll try to go quick here. Just 5 more minutes and then I should kind of be done. So I have this model, and what I'm going to do is I'm just going to show you that I'm going to create a model called C-Child Gartner 2020. And what it's going to do is it's going to reference that XGBoost model from a specific run ID. And it's going to create that model in my models version here. So if I go over to the model registry, let me search here. So you can see that I have this version here. This will bring it back to whatever I had. I can click on. Let me see here. So I have this one. So this is version 11. So version 11 of the model. So I can click on this. I can see kind of like what the run that actually took it, but you can see that the stage has nothing. And so we provide this kind of interface that allows you to kind of track your model from staging, production, and archived. So if I was a data scientist, or maybe a data scientist working on this, but I needed to create a model, but to move it to a staging environment, needed some kind of approval from maybe a tech lead or product owner, I could say like request to staging. I can put in a comment, right? And then it would kind of like do that kind of request. And then, like if a model is transitioned to a staging environment, there are MLflow webhooks that you can use in your, like CI/CD pipeline to maybe trigger some other stage in your pipeline when a model gets moved to staging or production or whatever. But then, so you can do that like manually, right? So I can say, hey, I want to transition this to staging. I want to transition this to archive. But you can also do it through the API as well. So I can say, hey, I want to get the latest version of my model. I want to find the plot associated with that model from my model in staging. And so the point being is that you can then take your model and you can load it back and do some maybe further analysis. You can move it to production and use different things like MLflow PyFunc to do some kind of inference on your actual model itself. So I think I'll stop there because I think, hopefully that gave everybody like a good overview of, kind of like what's possible in terms of data engineering, making sure that you can kind of have access to your data across your team, be able to kind of run experiments, track them within the workspace, and then actually deploy your model through this model lifecycle or kind of like a central model registry. And then you can either do it, kind of with the interface itself, like with some kind of graphical user interface, or you can do pretty much everything programmatically through the API. So I hope hopefully that gives everybody a good idea. And please, I'll stick around for any questions or any type of networking after this event.
Thank you, Chris. That was a great presentation.
Sorry for moving kind of quickly. I realized I kind of had a lot to go over in a short amount of time, but hopefully it wasn't too rushed and people were able to follow.
And we actually have a recording of this on YouTube, so if people want to review, there is a chance for that. But one important thing, like at AltaML, we actually don't have data scientists. We have ML developers, and you showed some aspect of that, like all this experiment tracking. There is more to that, but there is more of this practice of developing models versus scripting, which is very common at academia, and then try to deploy the models on production. And Databricks is a great platform that enables you to integrate all of these services that ML developers typically use.
Mm-hmm. Yeah, and I mean, like a great feature is that, you don't necessarily need the Databricks platform to do this, right? Like MLflow is open source, so you can do a lot of this kind of like model tracking and model management with just MLflow in general. So it's really, really good.
Yes, we actually got some questions, and I will maybe go quickly through them, and then if people have more questions, they can catch you at the table. So Peter from T-Rex AI, does the system protect the data in the lake from dangerous destructive commands such as SQL drops?
Yeah, so the Delta format does kind of give you that kind of reliability. The idea is that it's trying to give reliability to your data lake. So there are certain features of the Delta format, such as like ACID transactions, to kind of make sure that either data completely loads or it doesn't. There are things like schema enforcement to make sure that you're not going to load incorrect data to your data set, but also allows kind of like a flag for schema evolution if you did need to maybe add columns to your data set, because in data science use cases, very frequently you're building features and you want to kind of create maybe like some kind of like larger featureized data set, right? And so you want this ability to kind of like evolve your schema over time. And then so essentially what Delta is, it's a Parquet under the hood, but then it has like a Delta log folder that records all of the commits in format. So if you do different types of actions and transformations on your data set, everything will be recorded, and you can go back to a specific version and fix something that is being corrupted or dropped. That's it really.
Yeah. Another part of ML development, right? Version everything and have this data lineage, be able to reproduce everything.
Yeah.
Exactly. Yeah. So another question, also from Peter: do you provide host service, or does the customer have to link their own machines to the platform?
So you mean like do we host the clusters or
Yes.
Sorry, can you ask the question?
Do you provide host service, or does a customer have to link their own machines to the platform?
Yeah. So under the so Databricks, we do kind of like the decoupled storage and compute, right? So the storage is all the clients, so the data kind of like never leaves your data lake. And in terms of the compute, yeah, you do have to like manage your own clusters. So you can either do that. You just go into the clusters tab and you can kind of create clusters depending on whatever your size, whatever you need, right? So you can specify what type of machine I want. Do I want it to be like memory optimized? How many cores do I need? And then the associated cost with whatever you have. And then there's also the ability to make pools, right? So if you need your machines like hot, right? So there's no kind of like spin up time for your cluster, depending on your use case. You could also have this aspect of pools where you can keep a certain number of clusters on and ready for different types of work. But it's all managed by the end user.
Yeah. Okay. Trying to pick. I don't know if we have time to answer all the questions here, but maybe people can ask you later. There is a question from Ayush: for sensitive data which cannot be uploaded and stored in the cloud, is it possible to access the data in the platform during runtime? And maybe before you answer, maybe people can upvote the questions and I can select the next one. Right now, all of them have the same number of votes.
So I would say that the data definitely needs to be within some kind of cloud storage. And I mean, I would say if there's sensitive issues related to what type of data you might have, like there's a lot of like networking and security that goes behind setting up like a Databricks workspace. Like a lot of it is kind of done automated behind the scenes, but you can build your own, bring your own virtual network, create your own IP access lists. Your own virtual network, define your kind of like specific subnets, right? For both the data and the compute, right? Like separately. And then, like creating things like bringing your own specific IPs, right? That you might have. So so I'd say, like the data does need to be kind of like accessible within the cloud, but I think there are a lot of precautions you can take when having your data stored remotely.
Yeah, I would say that I see more and more trend that clients or industries realizing that data on the cloud is actually safer than data on the premise.
Yeah, I mean, if you're interested, I just Google this this article here, data exfiltration with Azure Databricks, and it kind of goes through like what, like, it can be super complex, right, in terms of different VNets and doing like different peering, whatever you might want to have defined. So yeah, like this is kind of like beyond the scope of this talk, but network security is definitely really important, especially if all the enterprises out there. So it's definitely something like on the top of our mind.
Yeah.
Yeah.
Okay, and all other questions have the same score, so maybe I will go with Daniel. How would your pipeline deal with more complex pieces of code, as in a non-sketch Jupyter notebook stage, but a proper code repo? And
right.
Daniel is not sure if it's a good question.
No, that's good. So, okay, so like let's say you're developing some kind of package. It can be seamlessly integrated using this repos tab. This is a bad example because I don't have anything in here, but this kind of like seamlessly integrates to a specific Git provider, so you can have like different repo URL. Yeah. Okay, so you can have like a specific Git repo. You can say, okay, I want to reference to like GitHub, Azure DevOps, and then so that code is then accessible as well as any of like the supplementary files that you might have. And what I would say is that let's say you're building a package, you could use something called like the Databricks API to kind of like deploy that code to a specific cluster, and then call that package within the notebook itself. So like a common solution pattern I've seen is, okay, I have a package, I have my build pipe. I'm going to like build that package, create maybe like a Python wheel if you're building a Python package, and then you would use the Databricks command line interface within your pipeline to then deploy that to a cluster, and then that cluster would then, or then a notebook that's running on that cluster could then reference different functionality in their pipeline.
Yeah. No, notebooks become quite more powerful than they used to be, and even Amazon use them on production. They designed the whole system to use them in production, so it's pretty much limitless what they can do. There are some problems with notebooks and unit tests and things like that. But
yeah, so for the person who asked that question, I'd refer you to this GitHub repo. So there's this Databricks Labs project, and there's this one called Csv Templates, and that kind of has a lot of that common stuff that you might want, right? Like, how do you actually build a package? How do you do your tests? How do you configure all the different hooks? And how would you actually build it into some kind of CI type pipeline? Thank you.
Yeah, great. Okay, thank you very much.
Going into affinity here.
Yeah. No, thanks. That's great. And there are two other questions, but let's maybe move to the tables and people can ask you. Thank you for showing us piece of ML developer work, and don't worry about the kid. It's like it's very frequent.
It's bedtime.
No, yeah, and especially at this time, it's like totally normal. I have often my daughters running into the meetings.
Okay, well, yeah, thank you. It was great being here.
Thank you.
So thanks, Chris. And Martin, I just wanted to end before we go into the meetup or the breakout session, and just say that our next meetup is going to be on May 5th, 2021, 1 month. So it's always going to be the first Wednesday of the month. And so we look forward to seeing you then. And also just to say is posted in the chat, if you've got ideas and suggestions for speakers, please send them to the email that's on the screen. And as always, I really want to thank AlphaML for sponsoring, Martian, your time, and Corey Jansen's time as well. We wouldn't be able to do this without AlphaML, so the community really appreciates that. I'll let you close off the event.
Thank you, everyone. And if you have time, please stay and network in the network part.